Problem number 4. We are given the graph of f, shown in this figure right here. We're told that there's a vertical tangent at the point over 2 up 0. So there's a vertical tangent right there. And we're told that there are horizontal tangents at the point 1 and negative 1. Actually, 1 comma negative 1, which is this point right here, and also 3, 1, which is that point right there. And the question asks, for which values between negative 2 and 4 is f not differentiable? Okay, so f is not differentiable when we have 4 possibilities. Possibility A was a corner. There are no corners in this graph, so that's out. Possibility number B is if there's a cusp. There are no cusps in this graph, so that's out. Possibility number C is where there's a vertical tangent line. We're told explicitly there's a vertical tangent line at x equals 2. So x equals 2 has to be part of our answer, which wipes out those 2 options. And finally, the fourth and final possibility is if the function has a discontinuity. And we can clearly see a discontinuity at x equals 0. So that is the second value on this interval of x in which the function is not differentiable. Yes, 1 and 3, the derivative is equal to 0, but the derivative does exist, and it's equal to 0. At x equals 0 and x equals 2, the derivative does not exist. All right, problem number 5. You're asked to find the derivative of this equation. Well, it might be beneficial to rewrite this ever so slightly before we move forward. The first term does not need to be rewritten because it's already in as a rational exponent. However, the second term, we have minus 3 over x to the 5th. We want to avoid the quotient rule, so we're going to move that x to the 5th up to the numerator, and the cost is that we turn the exponent negative. Now we've rewritten this function so that it's ready to be derived, and we can use our basic rules to get it done. We have a 1/2, then we have 4/5 coming down. That's our exponent. And x, we have to subtract 1. All right, so we have 4/5 minus 5/5, because 5/5 is equal to 1, so that's negative 1/5. So we have x to the negative 1/5 power. That's the first part of our derivative. Now we have minus 3 and then negative 5. We're going to bring the negative 5 down, multiply it by the negative 3 that's already there. So we have plus 15, and then x, and we subtract 1. So negative 5 minus 1 is negative 6. Okay, so now we have to match up our 4 answers with what we've written right here. Well, we can eliminate a lot of stuff right away because we see 15x to the negative 6, which we know is 15 over x to the positive 6, which eliminates C, and it eliminates B. So our answer is either going to be A or D. We have to look at our first term. In our first term, we see x to the negative 1/5, which would become positive if we move it down into the denominator. Option A has x to the 1/5. Option D does not have x to the 1/5 in the denominator. So D is out, and our answer is A. We don't have to do any more simplifying. We'll just use our test-taking skills. Okay, last but not least, problem number 6. If f is differentiable function, and f of 3 is 8, and f prime of 3 is 5, which of the following statements could be false? Okay, if f of 3 is 8, and f is differentiable, well, differentiability implies continuity, which means that f must also be continuous at x equals 3. And if f of 3 is 8, then the limit as x approaches 3 of the function must also be equal to 8. That's the only limit value that's possible in order for our function to be continuous, and our function must be continuous because f is differentiable. So this one's true. All right, now we go to B. We see the limit as x approaches 3 of f of x minus 8 over x minus 3 is equal to 5. This is our alternate form of the derivative. Okay, if you recall, we saw the limit as x approaches a of f of x minus f of a over x minus a. That was the alternate form of the derivative. See how this matches up nicely? Instead of having f of 3 right here, though, f of 3 is 8. That's why it's minus 8. And we have x minus 3 in the denominator, just like we see right here. So this is also true. That's our alternate form of the derivative. This is our original form of the derivative. Okay, this is f of x plus h minus f of x. All right, but we know that f of 3 is 8, so that's why we get to put the 8 there, all over h as h approaches 0. So x is replaced by 3, f of x is replaced by 8, just as we see right here, and we know that the derivative is equal to 5, so this statement is true as well, which means that D must be our answer. D is false. And in fact, D could be true, but we don't know for certain if D is true because we don't know anything about f prime near as x approaches 3. We only know about f prime at 3. And we have no idea what's going on as x approaches 3 of our derivative. Hence the reason why that one could be false.